So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with transformations with a focus on enlargements where you've got positive scale factors only. Now there will be a worksheet in the description below for you to download in which I'll work through the examples, so feel free to print this off before watching the video so you can work through it with me. Now enlarging a shape is to make the shape either bigger or smaller. Now this enlargement is based on its scale factor, which we abbreviate with the letters SF, not to get confused with sig fig. Now when enlarging a shape, you are basically affecting all the dimensions, in other words, all the sides of the shape. So you're not just going to be enlarging certain sides of the shape or certain parts of the shape, it's going to be everything. So all the sides are going to be affected. Now, in terms of the types of scale factor, now this is where it kind of comes into common sense of you understanding what the scale factor is. Now the scale factor basically tells you how much bigger or smaller you are making a shape, but usually applies to multiplying all of the lengths by the scale factor rather than dividing. And you kind of automatically think that when you're multiplying, you're automatically making the number bigger, but if you are multiplying a number by a number that's between 0 and 1, then, or less than 1 I should say, then you're going to make the number smaller. Now the types of scale factor that you can get is definitely something that is worth making a note of. And if I just put a little bubble around this, and we'll go through each of the stages. Now depending on what level of enlargements you're working at, whether it be at Key Stage 3 or Key Stage 4 or higher or foundation, will depend on the type of scale factor that you're more likely to get. Now when your scale factor is a number that is bigger than 1, then you are going to be making the shape bigger. If your scale factor is between 0 and 1, and that could be given as written as a fraction, so for example a half or a third or something even more complex, or a quarter even, then what you're going to be doing is you're going to make the shape smaller. Now this is where it starts going to high level enlargements, which I'll cover and go in more detail in another enlargement video. But when your scale factor is a number between -1 and 0, then what are you doing? You're going to be making the shape, not only are you going to be making the shape smaller because the scale factor is going to be between 0 and 1, but the negative means that you're also going to rotate that shape 180 degrees, which kind of links in with rotation. But again, this only really applies at high level, and also when you've got a center of enlargement, which is what the COE stands for, which again I'll cover in the next video. And also when you've got a scale factor that is less than -1, so -3, -4, etc., then not only are you going to make the shape bigger, but you're also going to rotate it 180 degrees. And that's definitely something that's worth noting. So in this video we'll try and go over where we're looking at positive scale factors, and then I'll cover negative scale factors in another video. Now before we continue, there's one thing that you need to note. Now that is that there are some very simple enlargement questions which we'll cover at the start of this video, but there are also some much higher level enlargement questions which we will cover in some latter videos. Now it is really important that you know what level of understanding you need and what you're going to be aiming for, so that you're not going to make a question more difficult than what it actually needs to be. So for example, a high level question might involve a negative scale factor, it might involve a fractional scale factor, it may even involve a center of enlargement. So if you are confronted with a simple question where there is no center of enlargement, you don't really want to be asking the question of where is my center of enlargement, because it may not be necessary for that question. And again, if that makes absolutely no sense, do not worry, we will cover this in all the videos that I cover on enlargements. Now before we get started, I'm just going to remind you that there is a copy of this worksheet that I'm going to be working through in the description below. So if you want to click on the link, and maybe I'd recommend that you print it off, because it's definitely going to be a lot easier by doing this by hand rather than on a computer. And you can work with the questions as I go through it, or you can have a look at me watching me do all these enlargements using the different methods I'm going to go through, and then obviously you can have an attempt at this and you can kind of practice what you've learned. So let's get started on this particular question. Now, so for this particular question, I need to enlarge this rectangle by a scale factor of 2. So in other words, I need to make this rectangle twice as big. Now, one piece of advice, now there is no center of enlargement. So if you're not too sure about what center of enlargement means, well, basically, if you're not given a center of enlargement or a dot, then you can draw this enlarged shape absolutely any way you want. Now, technically, you want to try and make sure you want to keep it on the page, and preferably using the squares that are available on the worksheet. But technically speaking, there is no specific location where your enlarged shape needs to be. So looking at this, what I'm going to do is, now I always recommend you pick a starting point on the object. Now remember that the object is the original shape. Let's just write that down, is the original shape, and the image is the transformed shape. So looking at this, I'm going to start now. What I might want to do is I might want to write down, because this is a polygon, so a shape with nice straight edges, I might write down, and horizontal and vertical lines I should add, what I might do is write down the dimensions of each of these. So it's going to be a 3 by 5. Now when I enlarge this shape, I need to make sure that the orientation is the same. So what I mean is that even though it's a rectangle, I don't want my rectangle to be sort of flat on its sort of base. Again, because I need to make sure it looks in the same orientation. So this rectangle is stood up, so I need to make sure that my image is going to be also stood up. Now from this, you also want to make sure you've got enough space. I'm going to pick my starting point here. So this point, this red dot, is representative of this green point on my image. Now what I'm going to do is I'm going to pick a direction, so I might want to go in a clockwise direction. So rather than going 5, I'm going to multiply that by 2, and that's basically what I'm going to be doing to all of these lengths. And why is it 2? Because the scale factor is 2. So rather than going 5 up, I'm going to go 10 up. So that's 5, and then count another 5, and that's going to be there. And then from there, rather than going 3 across, I'm going to go 6 across, which is going to be there. And rather than going 5 down, I'm going to go 10 down. And lo and behold, I've got my rectangle. Now again, it'd be very good practice for me to set a good example of using a ruler. So let's see if I can just cheat and use a shape facility on this, and there you go, and I've got my enlarged shape. And obviously what you then might want to do is, if it's a little bit difficult to see, you may want to just kind of quickly shade in that shape, but I certainly would recommend that you use a ruler because you may lose marks if it's not drawn correctly. And let me just edit my colouring there, because I've kind of gone outside the lines. It's a bit of embarrassing, but there you go, and there we're done. So looking at the next question, so again I've got more of a complicated shape. Now, when you have got a complicated shape, now some of you would be really good at these, and you won't necessarily need instructions. You may not need to do what I'm going to show you now. But what I'm going to do is I'm going to label these points. I'm going to start with 1, 2, 3, and 4. Now, as always, I'm going to pick a starting point of my shape, which I'm going to pick my starting point here, and I'm going to start at 1. Now, to go from 1 to 2, I need to use basically the column vector is 3 to the right, and none up. So now if I multiply that by 2, then I'm going to get 6 and 0. So from this point I'm going to go 6 across. So that's 3 and 3. So that's where my new number 2 is going to be. Now to go from 2 to 3, what I need to do is I need to go 3 across, 3 to the right, and 3 up. So that's going to be 3, 3. So again, if I multiply that by 2, and again, why am I multiplying by 2? Because my scale factor is 2. So if my scale factor is 3, I'd multiply these column vectors by 2. So here I get 6 and 6. Let me just put some box around here. So you go from 2 to 3, I'm going to go 6 across. So 3 and 3, and then 6 up, which then becomes here. I'm going to label that as a 3. And then I need to go from 3 to 4. Now 3 to 4 is going across to the right, to the left, 5 squares, so that's going to be minus 5, 0. So again, multiplying that by 2, I'm going to get minus 10 and 0. So I'm going to count 10 squares going to the left, so that's 4, 5, 6, 7, 8, 9, 10, and that's going to be there, and that's going to be my number 4. And then all I've then got to do is just join the points up like I would like a dot to dot. So here I've got there, and then point to there. And again, like I said, sometimes you might not need to do the column vectors. Some of you might be able to really good and just be really good visual sort of and have an eye for it, and you'll know exactly how to enlarge it. And like I said, there is no expectations on this image being in a particular place. And like I said, I always recommend that you do use a ruler and make sure that your points are on point. It's taking forever. There we go. And once you're happy with the shape, again, you might want to shade it. There's no marks for shading, but again, it just highlights it just to make it easier for whoever's marking your page. Now, generally speaking, now that shape does look odd, but it is correct. And Yeah, just double check. And so it, again, particularly shapes that are using diagonal lines where it crosses the lines and aren't vertical or horizontal lines may look a little bit weird. But as long as your measurements are correct, and it's worth just double checking in terms of column vectors, then you're going to be absolutely fine. So like I said, it's just a case of going through that now. A question I always get asked is, what happens if you're one square out? How would you know? And how accurate are the marking going to be? Now, if the marking was done correctly, then what would happen is a teacher or an examiner would have a tracing paper over correct answer, and all they would do is just match the tracing paper over your answer. If it fits perfectly, full marks. If it doesn't, obviously you're then going to lose marks. And some of these questions are worth more than 1 mark. You might get, let's say, 1 or 2 marks for every correct side that you correctly enlarge. It may go on from that. So let's have a look at our next question then. So again, this one's a little bit more confusing. Or say more complicated, but again what I'm going to do is I'm going to label each of these vertices, turning this question kind of into a dot to dot, in which I've got 6 points that I need to plot. Now again, you could go for the column vectors. I'm going to start my starting position here, so that's my number 1. So you go from number 1 to number 2, you need to go to the right 1 and up 3, so I'm going to go to the right 2 because my scale factor is 2. I'm going to go to the left, to right, sorry, 2 and up 6. That's 2, 3 and 3, so that's going to be there. Then from 2 to 3 I'm going to go across 2, up 1, so I'm going to double that and go across 4 and up 2, so that's going to be there. And then to go from 3 to 4 I need to go across 6 and then up 2, so that's going to be there. And then I need to repeat the process, so go from 4 to 5, I need to go down 2 because it's down 1 and left 3, so down 2, left 6, which is going to be here, and the next one's going to be there, and then all I've then got to do is join the points up with my ruler. And so let's just quickly do that. And your points should look very, very similar. I'm rushing this, so my points may not be hitting the exact marker. Not easiest softwares to use, but hopefully you get the point, which is the most important thing. This is where I strongly recommend that you watch the video in ×10 to speed up this process. And there we go, should have something that looks like this. And again, from there we can then shade in the shape of what it should look like so. So let's have a look at our next example. So again here we've got that little worm that's come up to say hello. So again I'm going to, now the key thing to remember here is my scale factor is 3. So again I'm going to have my starting point, and I'm going to go round in an anti-clockwise direction going through each of these points. So again, you could label it, it's entirely up to you. It's not essential, you're not going to get any marks for it, but again I need to mark down those 5 points. So again, picking a starting point, I'm going to multiply each of the distances going from the starting point, which is 0, all the way across to those 5 other points. So again, rather than go 1, I'm going to go 3, and I've got 3 up, so that's going to be 9, 3, and that's there. Rather than go 1 across, I'm going to go 3, 3, and that should be there. And then all I then need to do is use a ruler, join these points up, and let me see if I can shape and see if that does it for me a little bit. Right. Like so, and then hopefully if you've done that correctly with a ruler, I'm just trying to speed this up so you don't fall asleep. And there is my enlarged shape of scale factor 3. So with these next 2 examples where we enlarged by a scale factor of 3, I've kind of jumped ahead and just put them on the screen just to save you the time of falling asleep of watching me do these or try and draw straight lines using this software. But again, a very common question I always get asked when I'm teaching this is, so what happens if I've started enlarging a shape but I then go over the grid or the space that they've given me to enlarge the shape? Can I go outside the grid? Can I create my own squares so it fits in? What would I do? Unfortunately, you may lose marks in accuracy if you do go outside the necessary box. So it's something that you just want to kind of bear in mind of get the larger dimensions. So for example, if I look at this shape, you can see on the screen on the top, that the biggest length I can see is this one here. So I've got, that's going to be 4. So if I'm enlarging by a scale factor of 3, I'm going to be looking for a space of about 12 squares. So you want to make sure you've got at least 12 squares going up. And looking at the longest dimension going horizontally, that's going to be 3. So multiply that by 3, I'm looking at 9 squares going across. So again, you want to make sure you've got enough space before you start drawing, because like I said, what you don't want to do is be 90% into a diagram and then realizing, I haven't got enough space to finish it off, in which then you'd have to start again. And then have a look at the next one, which again is a little bit more confusing, but again, I just managed to fit it into the box correctly, and you can see we go from there. And again, obviously there should be some elements of accuracy of the points joining up, but again, stress that you do need to be using a ruler when you are completing these shapes. So then we move on to enlarging shapes with a scale factor that is less than 1. So here we've got a scale factor that is 0.5. And so what that basically means is I'm going to be halving the shape. Now, we're still going to be multiplying by the scale factor, and I certainly would still recommend that we have a starting point and we look at the points here. So looking at counting the squares, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And going up, I've got, that's going to be 4, 8, 10. So there we go, we've got a square. So what I'm going to do is I'm going to multiply each of these by the scale factor. So I'm going to multiply it by 0.5 times 0.5, and that gives me the dimensions of my image, which is going to be 5. So what I'm going to do is I'm going to pick a point. I'm just going to pick this point here, and I'm going to go 5 across, 5 up, and then likewise, and there I've got my shape. So I'm just going to kind of cheat and draw a square, and there I've got my enlarged shape. So although it's still enlarging, we're actually making it smaller. So it's a very common misconception that when we think, oh, enlargement, you're always making a shape bigger because it's got the word large in it. Not always the case. And there is my image that's been scale factored at 0.5. So looking at this one again, a little bit more complicated because again we've got diagonal lines, but the principle is still exactly the same. So again, I'm going to pick mark my vertices. So if I just do 1, 2, 3, 4. So to go from 1 to 2, well, that's going to be, I'm just counting the squares, that's 5 and 12. So that's 12, 0. 2 to 3 is going to be minus 4, 6. So minus 4, 6. And then 3 to 4 is minus 2, 0. And 4 to 1, well, again, don't need to measure that one because I'm just going to need to just connect the two together. So what I'm going to do is I'm going to multiply each of these by 0.5. And multiplying by 0.5 is the same as halving the dimensions. So this is going to be 6, 0. That's going to be minus 2, 3. And this is going to be minus 1, 0. So picking a point, I'm going to start my shape here. So again, following these dimensions, I'm going to go 6 to the right. So that's 3, 3. So there we go. And then I'm going to go minus 2 and 3 up. Then I'm going to go minus 1 across, and then I join those points up, which I'm just going to kind of draw freehand very poorly. Not too bad. And then we go, and there is my image. And so again, you can either do it by sight. You don't have to do these column vectors, but again, it may be just a technique that you might find helping just to get your idea of what it is you actually need to do. So let's have a look at this shape again. So a little bit more complicated, and particularly with these diagonal lines. And again, you could go through the dimensions yourself. So again, we're going to use a scale factor of a half. So I'm going to be halving the sort of dimensions. So again, I pick a starting point. Let's pick this one here. It's an empty space. So I've got 3, 6, 9, 12. So 12 is going to be 6. So that's 4 from there. Then I'm going 4 up. Now halve that. That's 2. So that's going to be there. And then going from this point to my top point, I'm going to go to the left 4 squares. So if I halve that, I'm going to go left 2 squares. And I'm going to go up 8 squares. So I'm going to halve that and go up 4 squares. And again, all I then need to do is join those points up, preferably with a ruler. And again, it's just worth just highlighting the shape, and there we go. So again, not having done the column vectors, but if I wanted to, then that would be absolutely fine, just to get your head around. Because again, rushing these questions could cost you vital points, or marks I should say. So looking at this one, so here we've got a scale factor of a quarter, or 0.25. So again, the scale factor of 0.25 is the same as a quarter, so I'm going to be dividing each of the lengths by 4. So looking at this, again having my starting point, which is going to be here, so I'm going across 4 and I'm going up 8. So looking at that, all I need to do is times those lengths by 4, so 4 times 0.25 is 1, and 8 times 0.25 is 2. So it's going to be a dimensions of 1, 2, so it's going to basically look like this. And there we go. Again, looking at this next shape, again we are using a scale factor of 0.25. So again, I'm going to pick a starting point. I'm going to pick this point here, so I'm going to use this one here. So again, this is 4, 4, and that is 8. So again, dividing each of those dimensions by a quarter. So 4 times a quarter is 1, and then 8 times a quarter is 2. And then that's going to be 1. So what this shape's going to look like is going to look like that. And then looking at moving on to the next one, so again a little bit more complicated. So again, I pick my starting point. So I'll put starting point here. So I've got 4 and I've got 8 again. So again, dividing 4 by timesing 4 by a quarter, you get 1. And then 8 times quarter is 2. And then from this point to this point, well, it's going to be 4 down, 4 across. So 4 times a quarter is 1, so it's going to be 1 across, and that's going to be there. Then all I then need to do is join the points up, and it looks like that. So again, very, very small. Again, we are making this 4 times as smaller. Now when we move on to ones that are a little bit more complicated, so here we've got a scale factor of 1.5. So 1.5 is the same as 3 over 2. So what we need to do here is we divide the length by 2 and then multiply by 3. So we divide by the bottom number, we times by the top. So again, writing down the dimensions, I've got 4, 2, 4, 2. Now because the scale factor is 1.5, means we are going to make this shape bigger. So what I need to do is 4 times 3 over 2. So 4 divided by 2 is 2, times 3 is 6, and 2 times 3 over 2, or 2 divided by 2 is 1, times 3 is 3. So what I need to do is I need to draw a rectangle with the dimensions of 6 across and 3 up. So 6 across is going to be here, 3 up is going to be there, and again, using my common sense and my graphical eye, I can match those points up. And again, strongly recommend you use a ruler. I'm just doing this so again you don't fall asleep watching me do it, unless you're watching in ×5. And there we go. So moving on to the next one. Again, looking at the dimensions, I've got 2, I've got 4, and I've got 6. So again, I'm using a scale factor of 1.5. So here I'm going to do 2 times 1.5. So again, 1.5 is 3 over 2, which is 3. 6 times 3 over 2 is going to be 9. And 4 times 3 over 2 is 6. So looking at those points, so rather than going 6, I'm going to go 9. So that's 3, 3, and 3. So that's going to be there. And rather than going 4 up, I'm going to go 6 up. So that's going to be there. And rather than going 2 across, I'm going to go 3 across. So that's going to be there. Then all I then need to do is join the points up like so. There we go. And we just shade that in to have our now shape. Now again, if you're not too great with diagonals, then I strongly recommend that you use the column vectors and use it like a dot to dot. It is very time consuming, and yes, a lot of people can't be bothered to do it, but it might help you. So 1, 2, 3, and 4. So you're going from 1 to 2. Well, that's going to be a column vector of 6, 0. 2 to 3 is minus 4, 4. And 3 to 4 is minus 2, 0. So again, all I then need to do is multiply each of these by 1.5 times 1.5. Again, or just multiply, divide by 2 times by 3. So that's going to be 6 divided by 2 is 3 times 3 is 9. So that's 9, 0. This is going to be minus 2 minus 6, 6. And then we've got 2 divided by 2, which is 1, times 3 is minus 3, 0. Again, so following those instructions will therefore give you the correct dimensions of what you then need. So I've got 1, 2, 3, and 4. And then just connect 4 and 1 together. So I don't need to do 4 to 1 because again, it's unnecessary. Now moving on to the next question, as you can see it's kind of overlapped, so you will not lose any marks if your image overlaps your object as long as it's the correct dimension, the correct sizes. And again, so here, now moving on to the next one, here we've got a scale factor of 2.5. So again, I strongly recommend that you convert 2.5 into a fraction, which is 5 over 2. So what we're going to do here is with the lengths, we're going to divide by 2 and then multiply by 5. So looking at our starting point, which is here, I have my starting point, which is here, we're going to make it 2.5 times as big, so more than 2, less than 3. So here I've got 4. So 4 divided by 2 is 2, times 5 is 10. So I'm going to go 10 across, that's 5. And then we've got another 5, which is there. And then rather than going 2 up, I'm going to be doing 2 divided by 2, which is 1, times 5 is 5. So then what I'm going to do is do that, and then all I then need to do is join those points up with those two lengths, and there is our enlarged shape. So it's just a case of just being comfortable with decimals and fractions. So I strongly recommend, so if you had 2.5, convert that in, so it becomes 5 over 2, 3.5, then that would be 7 over 2. So what I'll do is I'll divide each length by 2 and then multiply by 7, and that will give me my dimensions. So looking at the next two, and these are the last two, so let's just quickly do these. If you're still with me, so again, we're going to have this point here and this point here, and that is 6. That's 4, that's 4, and then we've got our final point. So again, I'm going to do 6 times 2.5. So divided by 2 is 3, times 5 is 15. And then 4 times 2.5, so again, we're going to times 5 over 2, that is. So again, 4 divided by 2 is 2, times 5 is 10. So again, picking a starting point, which I'm just going to pick here. So rather than going there, now this one I probably will need to overlap because I need 15 squares going across. So I'm actually going to start it at this point here. So that's going to be 5 and then 10 and 15. So that's going to be there. And then I'm going to go up 10 squares. So that's 5 and another 5, which is there. And then I need to go another 10. So that's 4. 10 is there, and then join those points up, in which again I'm going to use my straight edge to do that correctly. So and like I said, there is absolutely no problems with your image overlapping your object, again, because all it's about having the correct dimensions. There we go. And obviously then if you want to shade it in, that's entirely up to you. So looking at the last one then, so again a little bit more complicated because we've got diagonal lines. So I'm going to pick a starting point. So let's go for this bottom here. So I'm going to label that 1, 2, 3, 4, 5, and let's go from there. So again I'm going to use my column vectors. So 1 to 2 is 4, 2. 2 to 3 is minus 2, 2. 3 to 4 is 0, 2. and 4 to 5 is minus 4, 0. So again, I'm going to multiply each of these dimensions by 2.5. Again, you can either use your calculator or you can just use the fraction. So again, it's 5 over 2. So 4 divided by 2 is 2, times 5 is 10. 2 divided by 2, and that's going to be 5. And then here I've got, it's going to be minus 5, 5. And it's going to be 0, 5. And here minus 4 divided by 2 is minus 2, times 5 is minus 10, and that's 10, 0. So picking a point, which I'm going to go for this point here. Again, I'm going from 0 to 1, so I'm going to go 10 across. So that's 4, 5, 6, 7, 8, 9, 10. And then 5 up, so that's 3 and 5, so that's there. So that's my new number 2. And from 2 to 3, I need to go 5 to the left, it's there, and then 5 up, which is here. And then I need to go from 3 to 4. I'm going to be going up 5 squares. So this, I'm going to have to start again because I haven't got enough room. So I'm going to have my 1 here. I'm just going to move it down 2 squares. So from 2 to 3, so that's going to be there. And then 3 to 4, I need to go up 5 squares, so that's going to be there. Just get rid of the purple markings. And again, just proof that it's easily done of not having enough space. Let's get a pen. And then from 4 to 5, I need to go minus 10. So that's 5, and then another 5, which is, and then I just need to connect those points up. So again, making full use of this grid, we get something that looks like now. Part of the challenge of this particular question is that you automatically think you've gone wrong, and this is again a valid reason why you need to use a pencil whenever you're drawing any diagrams in maths, because it is very, very easy to go wrong. And without using a pencil, it just means you're going to have to start all over again or ask for another sheet. And there we've completed our shape. Now again, there will be a copy of this worksheet in the description below for you to either have a go again or for you to watch the video and check your answers, and that's entirely up to you. And like I said, in the next video of enlargements, we'll be focusing on what happens when you've got a centre enlargement and the little twist on these questions.